All right, welcome back, Math 8 students. I am here with lesson 7.4, notes, equations with many solutions or no solutions. And so what we're doing is we are building on lesson 7.1, 7.2, 7.3, and we are now seeing what exactly it is that we are doing when we are setting these equations equal to each other. And going further and seeing that some of these equations have many solutions, some of them have no solution, some of them have one solution. Up to this point, all of the equations that you have worked on have had only one solution. But they can have many and they can have none. And so we're going to see what that looks like. But we're going to kind of connect some big concepts here before we get into that. So I want you to think about when we are solving linear equations with variables on both sides, what is it that we are actually doing? We're trying to find, essentially, where these two equations, if we were to graph them, intersect. What is that x value? And so thinking about what it actually means, what a linear equation is that a linear equation is an equation that represents a straight line. I'm going to run out of room here. That line should be a little bit bigger. So if we have a straight line, that means that we can graph these. We can graph the linear equation. Now we're not graphing these yet, but that is where we're going next. So I want you to keep that in mind. Again, we're connecting big concepts here, thinking about the big picture. So when we have two equations that we set equal to each other, what we are essentially doing is graphing two equations, or both equations, and finding their points of intersection. So they could have one point of intersection, they could have many points of intersection, or they could have 0 points of intersection. So that means that you can have equations with one solution, which would be 1 point of intersection, many solutions, or no solution. And so what that looks like is, I'm going to just give you a little visual here before I get into these examples. So I'm just going to, because I'm not going to actually graph these ones, but I do want to show you what this looks like, what the visual representation is. So I'm not graphing these equations right here. I'm giving you a visual example of if I have one solution, that means that I've got two lines, and those two lines only intersect once. And in this case, let's say that I'm counting each of these units by 1, this intersection, right, where my x value is, would be 2, right? If that's 2, so this would be x equals 2, right? So these, again, this does not represent this equation here. This is just a general example. So when I have an equation set equal to another equation, when I solve for x, I'm trying to find that point of intersection. If they have one intersection point, it is going to give you one solution. If I have many solutions, this is when x equals 2, or x equals any number. If I have many solutions, I'm going to have one line, and the second line is actually going to end up being the same line, right? So it's going to be one line that lies on top of another line. So when I solve this, I'm going to get a true statement, and I'm going to get something like x equals x, or 5 equals 5, or -8 equals -8. So that's what it's going to look like when you solve this equation and have many solutions. And finally, the last thing that you'll get is you can have something with no solution. Okay? And so that means that you have one line, and that other line is actually going to be something that runs parallel to it. They're never going to intersect. They're never going to have a solution, right? So they're going to run parallel to each other, and you can actually look at these equations and they'll have the same slope, right? Because this is going to have the same slope as this one, and that indicates that they're parallel lines and they will never touch. So when you solve these equations, you're going to get a false statement, meaning something like 0 equals 2. 0 doesn't equal 2. 0 will never equal 2. So this is a false statement. Or maybe something like 5 equals negative 13. Again, 5 will never equal negative 13. That's never going to be a true statement. So when you get something that's false like this, something that is not equal to something else, that means that you have no solution to that equation. Okay, so that's just kind of the big picture. That lets you know where we're going next with these, and it gives you a visual representation of what you're doing. So let's go ahead and move into solving a couple of these now. We've got 3 equations. Each one of these will either have one solution, many solution, or no solution. So I'm going to show you what that looks like. So the first thing that we're going to do here in this first one is solve, right? We're going to try and solve for x. So we need to first see that we have no fractions, we have no decimals, so we have nothing that we need to eliminate there. We have nothing we need to distribute. So this equation is ready to solve by getting our variables on one side and our constants on the other. So the first thing that I'm going to do, and it doesn't necessarily matter where you start, you can start by moving your constants, you can start by moving your variables, you just have to make sure you're moving them using the correct inverse operation. So in this case, I'm going to go ahead and move my 3 here. Since this is a negative 3, it's minus 3, which means it's a negative 3. I'm going to add, because that is the opposite. That cancels it out on this side of the equal sign and combines it on this side of the equal sign. So this is now 13 plus 3, which is 16. Bringing down everything that I haven't changed, so 4x equals 2x plus 16. So my constants are combined. Now I need to combine my variables. So I cannot move this 4x because that's going to leave me with nothing on this side of the equal sign, and I have to keep something on each side. I have to keep my variables on one side and my constants on the other. So I'm going to move my 2x, and this is positive, so I need to subtract because that's going to cancel it out on this side and let me combine it on this side. So now I have 4x minus 2x, which is 2x. Bring down everything I didn't change, so equal to 16. So now what I have is 2 times something equals 16. 2x times something equals 16. This is multiplication, so my inverse would be division. Dividing by 2. 2 divided by 2 is 1x, right? So I'm left with x. And 16 divided by 2 is 8. So here I am with my solution, x equals 8. Now if I look back to what we were talking about earlier, I have a true statement. That means that x equals something specific. It equals one specific thing. And if it equals one specific number, then it is a true statement and it has one solution. Okay, so this equation here has one solution. If you were to graph these two lines, they would have one point of intersection. Moving on to this next one here. First thing we got to do is check, see if we've got any fractions to eliminate. No fractions to eliminate. Second thing we need to do is check and see if we've got any decimals to eliminate. No decimals to eliminate. And then we're looking to distribute. And we do have to distribute in this one. So I'm going to distribute that 2 inside my parentheses to each term. So I've got 2 times 2x, which is 4x, and 2 times 1, or negative 1, which is negative 2. Then I'm going to bring everything down that I didn't change. So now I have 4x minus 5 equals 4x minus 2 minus 3. So I have two constants on the same side of the equal sign. I'm going to simplify those before I try and move anything across the equal sign. So negative 2 minus 3 is going to give me negative 5. So I've got 4x minus 5 equals 4x minus 5. Okay, so you can already see that you have the same thing on each side of the equal sign, which indicates you should get the same solution on each side of the equal sign. Now this would represent two lines, two of the same lines, right? So these lines would graph right on top of each other and you would have many solutions. I'm going to continue to solve this so you can see what that looks like. I'm going to combine my terms, right? So I'm going to combine my constants first. And it doesn't matter, you could combine your variables first if you wanted. So now I have 4x equals 4x, negative 5, positive 5, canceled out, so this is 0, right? So plus 0. And then I have 4x equals 4x plus 0, which is the same as 4x equals 4x, right? So what I would do from here is I could, I would minus my 4x, right? And I have 0 equals 0. So I have a true statement. Now, I'm just going to take a little tangent, and let's just say that instead of moving my constants, I decided to move my variables first. So I'm just going to rewrite this over here. 4x minus 5 equals 4x minus 5. Let's say I decide to move my variables first. So I'm going to minus 4x and minus 4x. So those cancel out on both sides now. And now I have negative 5 equals negative 5. So again, I have another true statement. 0 will always equal 0. Negative 5 will always equal 5. But since they are equal to each other, that tells me that these are two lines that have the exact same slope and the same y-intercept, so they have infinitely many solutions. So this equation has many solutions. So the last one that we're going to look at is this third equation here. I'm going to use a different color because we got a little crowded over here. And I'm going to go ahead, first check, no fractions to eliminate, no decimals to eliminate, nothing to distribute, so I can go ahead and start simplifying by putting my variables on one side and my constants on the other. So I'm going to go ahead and start by moving my constants. So I'm going to go ahead and subtract 2 from each side. So that cancels out on this side of the equal sign. I have 4x equals 4x minus 7. Okay. Now I need to combine my my variables. So I'm going to subtract 4x from this side. Remember, I can't move this one because then this side of the equal sign is empty. So it cancels out here, but it also cancels out here, right? So this becomes 0. 0 equals negative 7. Now this is a false statement. 0 will never equal negative 7. Never. It just isn't the way it is. 0 is 0 and negative 7 is 7. So this is a false statement, and this means that this equation has no solutions. They will never intersect. They are two lines that are parallel. And so if you remember what I said earlier when I was talking about this graph up here, that they would have the same slope, we can take a look and notice that these have the same slope and different y-intercepts, right? Which means they start at two different points but travel in the same slope, so they run parallel to each other. So that's another little thing you can look at there. As opposed to this one back here, what also has the same slope but has the same y-intercept, right? So that is the same line. So here what we got, we jump back over here to no solution. We've got 4x, right? Plus 2 equals 4x minus 5. Same slope, different y-intercepts. When we solved it, we found that 0 equals negative 7, which is a false statement. There is no solution. If you were to graph these two, you would have two lines that never intercept. Okay. So the next thing that you'll be doing in this lesson is writing equations when you're given the number of solutions. So you're going to have to work backward. So you're going to have to write, like for example, write a linear equation that is one variable and no solution. So remember what the rules are. This is just a copy of what we had on the other side, right? If you have one solution, you're going to have the final result being x equals a number, right? So like x, for example, x equals 1. If you have infinitely many solutions, you'll have the same number. equals the same, a number equals the same number, so like 1 equals 1, for example. And if you have no solutions, you're going to have a number that is not equal to another number. So you might have something like 1 is equal to 3, which is a false statement. 1 is not equal to 3. So you're starting with the result and working backwards. So in this case, let's go ahead and create a linear equation in one variable that has no solution. So you're going to start with a false statement, right? It has no solution, so I need a false statement. So I'm going to, okay, well, I'm going to pick this. 3 equals 5. That's a false statement, and I'm going to start there. So start with a false statement. Okay, and then I'm going to add the same variable term to both sides. So I'm going to go ahead and add x to both sides. So I'm going to say, okay, well, 3 plus x equals 5 plus x, right? So now I have the same slope and 2 different interceptions. And so then you can go ahead and add more to that if you would like. You can add the same constant to it. So you could say, okay, well, I want to add 7 to both sides. So plus 7 plus 7. And this is just to build a new equation. So then I have 10 plus x equals 12 plus x. And that's another. So this is one equation with no solutions. This is another equation with no solution. And so you just start with the results, add the same thing to each side, and then you'll end up with two equations, or an equation that is not equal to each other, and you will have no solution. You might be asked to build a linear equation that has one solution, or a linear equation that has many solutions. Okay? And so you're going to start with the end in mind. If you need to build something that has many solutions, you would start with a true statement where one number equals the same number, and you would build from that. If you were building a equation that has one solution, you would start with a true statement, and you would have a variable equal to a specific number, and you would build from that. Okay? So you work backwards when you're building equations, and that's tough. So when you get to these questions in class, and on your homework that's going to be, looks like numbers 9, 10, 11, and 12. When you get to those, if you are confused, make sure you're asking for help, because they're tough. They are tough, and you got to think backwards. So that is all I have for the notes today. It was a little bit longer, but this is the last notes for Module 7. We're going to have a few days of review. There'll probably be a review video for you to watch. It will be optional. And then we'll be taking our module test sometime next week, probably. All right, if you have questions, guys, you should be writing them down as you go through this. Bring them to class, and we'll go over them. I will see you in class.